guys, this is Alan from Plangora, and we're starting a new series about Elixir, and we plan to release about one video a week, and we're starting with this video. So this is just a very simple introduction to the Elixir programming language. Now Elixir is just a fantastic programming language. It's a very simple syntax that is, quite honestly, a little bit deceptively like Ruby. But don't get fooled, okay? It's definitely not like Ruby at all. And we're going to show you why. Now, Elixir itself is what we call a functional programming language. Now, this is totally different than object-oriented programming languages in the fact that functional programming languages are a lot easier to parallelize. They're easier to keep track of state, and they have immutable data structures. And so you might be asking yourself, why would we want immutable data? That doesn't make sense. Data always changes. Well, we can actually counter that by showing you how this actually is done in a functional programming language, where we actually just make a copy of that data and we just mutate the copy of that. And I'll show you more a little bit later on. Now, Elixir was created by a guy named José Valim. He wanted to find a better and easier way to run code in parallel. Now, José Valim was actually in the Ruby programming language community, and he was actually one of the people in Ruby on Rails, in the actual core team. And he started to look at how can we better run Ruby, or better run code itself in a parallel way. Because this happened just about the time where Ruby on Rails was becoming, well, they were starting to show more that you could actually run Ruby on Rails in a parallel way. And through his searching, he managed to find a programming language called Erlang. But he thought Erlang was just not quite right. And we can talk about that some more later on. Now, the benefits of using Elixir, and actually that comes from Erlang itself, is that it's made for massively concurrent or parallel applications with a very long lifespan. Now, the reason for that is that Erlang itself was actually created to run telephone switches. So can you actually imagine making a phone call and the system not being able to be used? It's very rare. Now, imagine that you're on the phone with somebody and somebody else makes a phone call which causes your phone call to crash. Wow, that would just not be good at all. So the guys who created Erlang, which was at a company called Elixir, well, they came up with this programming language called Erlang, and as we go on, I'll have to show you more, but they actually made a way that you can actually have all of these concurrent phone calls, and if one ever broke, all the others would be fine. And so lots of systems which require a long uptime and lots of concurrent connections actually use Erlang. So some couple examples I wrote down is WhatsApp. Now WhatsApp is massively using Erlang for their communications. They fit something about 2 or 3 million connections, I think, maybe even more by now, on just one server. And actually, the original Facebook Messenger was also written in Erlang. Now, I'll go ahead and be honest with you, it's already been rewritten in C. Now, Facebook has a lot more C developers and a lot more budget than a company like WhatsApp. In fact, WhatsApp, when they were bought, they just had, I think, about 30-something or 40-something engineers. Of course, Facebook has way more engineers, and they have a lot more C. But it just goes to show you that Erlang really can do quite a lot. And the reason for that is in its history. Now, something else that's really great about it is that it can scale both horizontally and vertically. Now, when we talked about concurrent applications, so the difference between concurrent and parallel is that when concurrent, you have different independent processes or different independent threads of execution running. Okay. Now, parallel means that you can run multiple concurrent operations at once. So with concurrency, you can then have parallelization. And now, the thing is, because Erlang, and therefore Elixir, has this high concurrency to it, it's able to actually use all of the CPU cores on your machine. And then we'll show you some of this later on. But just keep in mind that the more CPU cores you have, the more you can actually handle, because Elixir and Erlang itself can actually scale across all of your CPU cores and use your machine very, very efficiently. Don't forget that Erlang itself was actually created in the 80s, and so it's made to run on these very, very low hardware type of devices. And also, it could scale horizontally, and I can also go into that much later. But this means that you can actually talk to other Erlang machines across a network. And this is built in to the actual programming environment itself. And so I cannot not tell you about some disadvantages that it has. A very, very big one is that it's not computationally fast. It's not made for computations, right? It's made for very consistent, low latency kind of feedback, right? Like telephone switches, WebSocket connections, these kind of things. But it's not very good at crunching numbers. Something like Java or C, these other kind of languages can crunch numbers much, much faster. But you can make up for that by actually splitting up your problem and actually running it across all of your cores. That may actually help. Or you can just, find another way to do this. But this is something to keep in mind, okay? Elixir isn't great for all types of solutions. And one of them is computation. Now, another thing to keep in mind is that Elixir is a compiled language. So some may say this is an advantage, some may say this is a disadvantage. But in this case, of people who are used to running, say, Ruby or JavaScript that don't need to be compiled, well, it is a compiled language, so you're going to have to recompile your code sometimes. And we can talk some more about this. But there's actually ways around this. And there's actually some what they call hot code reloaders, which can actually recompile your code as it's running. And then you don't need to worry about this in development. But it's something to keep in mind during production. Another thing to keep in mind, which is I think quite unique, because most compiled languages are actually what they call typed languages. But this is dynamically typed, meaning that there's no actual type system. Now, this could be both a blessing and both a problem. But because we have a way to easily recover from errors, which I'm going to go into much later on, this is not such a big deal, but it is something to keep in mind. And there's also ways around this by using something called a dialyzer. And that's something else I can go into much later on, which can actually run through your codes of execution to make sure that you handle all kinds of different cases. And so again, I want to talk about this and make this very clear. Elixir is for long-running concurrent systems, okay? Things like telephone switches, chat programs, these kind of very long-running kind of things. It's not a system use language like C, Golang, or Rust. These ones are very what I call system use languages, which are ones that used to actually do some system-based operations, right? And I'm not going to go into this. I think you can do this yourself, but if you go to this website, elixirlang.org/install/html, this will show you how to install Elixir onto your system. So that is it for our first video. Let's catch up later. See you next time.